Let's take a look at some more problems here with expected value and standard deviation, how we can apply that. Here's a problem that we would do in class, but here's the answer just in case you missed it here. It would be a group practice, working in groups. It's a little bit challenging. Just again, being able to come up with the distribution first, right, and these interpretations of them. So I'll have you take a look at that. But again, like this idea of 1.1 cars, we don't sell 1.1 cars, right? It's the average idea that it's kind of close to 1, what we expect to sell per Friday morning, right? And that's kind of where that value is in terms of how I reason with it. And then you can, again, using technology, get the standard deviation, right? And then the interpretation, 0.943 cars. Again, it's an unusual number, less than 1. So the number of cars sold on Friday typically vary by 0.943 cars from the mean, right? So still, essentially, if that's almost a 1, so I would say between 0 and 2 cars. That's what we would expect most to be, right? Again, kind of really just simplifying the idea of standard deviation with that. And then these last two, again, you can see the solutions, but I really want to go through this expected value of the lottery ticket. And a lot of students omit or forget the -2 here, that you lose $2, right, this percent of the time or this often. And so you win this amount, this percent of the time, or with this probability, right? But notice the $5 you win, but it's really 3 because they keep your $2 for the lottery ticket. So you can see in red here those values that you actually win. So you have to subtract 2 because that's what you're actually taking away. And then you lose 2 this often. Now this number, again, I needed a calculator to calculate it. You can see the with the variable x, the value of the ticket or the amount won or lost, right? You see the probability of that. You have to do 1 minus, right? 1. So we're using the complement of the chances you're going to win. So I added all that up and 1 minus that, and you get 0.9889998. There we go. And so then you would end up getting that expected value, which I need to write in for you. So here it is, what it will look like on StatCrunch here. So you can see the values were converted, the fractions to decimals, plugged in, and you can see an expected value of -91 cents. You expect to lose 91 cents. This is a dollar situation, so -0.91 in this case here. Sorry for my writing there. That's what you would have when you calculate that there. So again, the lottery ticket, in the long run, you'll be losing 91 cents per ticket you buy, or about $1, right? So you're not going to win in the long run, other than if you win this one, but that's only one person, right? That's big jackpot. You'll see the same one for playing cards. Take a look at the numbers: 1/4 and 3/4, 5 and -2, right? You win 5, otherwise you lose 2. Now notice I'm not paying, so you're not subtracting 2 from the 5 in this case, because you either win or lose. In this case, you buy the ticket, and then this is what you win. You have to account for what you paid for the ticket. And so this one still has an expected value of -25 cents. So this is not a fair game. You expect to lose in the long run. This one here is probably the hardest one. We would talk about it in groups. It's a little bit of algebra here. You're looking for the value in this case. But again, it's a very applicable situation about these extended warranties. The companies know, right, a certain value to charge so that they still make a profit. So even in this case, to break even, they just have to charge you $4.64 for the warranty. Right, and then in the long run, with their estimates of how often they have to replace their products, you can see that. And then if they charge you $10 for the warranty, you pay $150, right, for, let's say, the object, or $300, whatever it is you're paying, and then you buy the warranty. The company will break even at $4.64. So even when people return it, they're still going to make money because of the 97% chance that they won't. So they're making money off 97% chance, 97% of the people, and losing only 3%. So you can see anything over 4, they make a profit on you. And so I don't like extended warranties It's hard to, but sometimes it's worth. You don't want to take the risk and you buy it.